Welcome to the lesson. Here are some questions. Of a what? Where? Zoom? Yeah. Discord. I want to see. I know see Zoom Discord thing. Liar. Who still wants me to stay on 1, 2, 3? ABC. Okay. One more minute, yeah? Can I at least scroll past B? You're working on C? Are you looking at June or July? Yeah, it should be July 17th through 19th. It's the same basically. Yeah, I'm gonna scroll down. Height. Give me a height. You got enough to find a height.
Look.
Can I scroll down to F? Give you all an F? Okay, 2 more minutes. I do want to hit all the topics, or as many as we can. Anthony, you're in radians. Okay, time's up. Sorry to rush the last bit, but we've spent almost a third of the class on one of the weeks. So let's go. This is, fortunately, some of this is real fast. What kind of lens is that? This is a concave, also called, which is diverging lens. Through the focal point, in particular, through the far focal. Mirror? Yeah, on the other side. What mirror are you talking about? Boo. 2 centimeters. And for this, you use the equation 1 over f equals 1 over di plus 1 over dou, and say that if the object distance goes to infinity, then f equals di. Again, here we use the 1 over f equals 1 over di plus 1 over dou. If we plug in negative 100 millimeters equals 1, well, I could just subtract off, minus 1 over 200 equals 1 over di. Image position is, let's see, 100 plus 200 is 3 200ths is 67. And then at the end of the day, we use magnification equals negative di over dou, and say negative negative is 67 over 200. It's a factor of 1/3. Can you guys even see the 1/3? Not too small. Negative image distance over object distance. Di over dou. That's one of the 2 equations I gave that day. Good? Sure. Okay, real image is projected 5 meters away. I was totally guessing the size of this projector system, and I think I got it wrong. So I give you the focal length is 25 centimeters. I give you the object distance. What can you do immediately with that? I find 1 over f equals, oh my God, it's like there's only 2 equations. 1 over y plus 1 over dou. 1 over dou plus 1 over di. And I get 1 over, let's see if I want to put this in the same units, 1 over a quarter equals 1/5 plus 1 over dou. What is that? What does that work out to be? 26 centimeters? That's part of it. And then, huh? One over 0.2. Where's the 1 over 0.2? Sorry. 1 over f. I said 0.25. If I'm using 5 meters and 25 centimeters, I want those in consistent units. Okay, and then the second part, how big is it? If the image is 2 meters tall, so I could use the equation magnification, which is image over object, 5 meters over basically a quarter of a meter again. what is that? 5 over a quarter is something like a factor of 20. So if the image is 2 meters tall, this would be 10 centimeters. Height of the object is like 10 centimeters, right? 0.1 meters times 20 is 2. Okay, I've done a bit. Let me ask for questions, especially since I did not leave enough space on the PDF for me to write vaguely. If you want to ask a question about anything. What's the 20th of 2? 20th of 2 meters is 0.1 meters. I'd also call 10 centimeters. 0.1 meters would also get full credit. Not that I'm going to give you things that those are 2 different responses. Multiple choice for the win. Yeah, that's yes, no, maybe so. Okay, and the last thing, index of refraction, 1.33, use the law, 1.33. So n1 sine theta 1 equals n2 sine theta 2. So I give you the index of, well, let's see, maybe if I should say, it enters, methinks it would make more sense to call that the n2. N1 for air is really freaking close to 1. .2 degrees. You good? Got a bunch of people got this right. Not everyone, but a bunch. Congratulations, you got this right. If you didn't, ask. You know the equation. Do you know what goes where? For reals? Okay, for reals, yeah. Are you happy? I just bought some ham radio equipment because I'm me. And I have a 5-watt speaker that will be putting out Morse code, oh yeah, all night long, that I will set how far away do I sit from it? I bend my face down to like 1.5 meters away from it. Assume sound comes out in a hemisphere because there is a table underneath it. Hey, I should double check because it might have been involved since geometry. Everybody know what a hemisphere is, yeah? Half a sphere? Cut a sphere in who? Okay, good, just checking. Assuming Sprouts heads over a hemisphere and my eardrum is, oh God, what was it? About half a centimeter, right? Find the power delivered at my ear. Let's just do this one at a time. I need to speed up so you can see a reasonable sampling of questions. Should be louder in here. Talk to each other. Like the crazy farmer. Ah, yeah, it's God, who made it? I've seen this before, but who did the film? That's neat album. Gesundheit. Hint, first find the intensity at the eardrum. Then find how much power that intensity transfers in. I didn't teach you guys decibels, right? Right. I cut that out of the curriculum. I'm sure I didn't teach you decibels. Okay. And here's H. Gesundheit. Follow-up question H. Somebody stands twice as far away. Don't do the calculation from scratch. They stand twice as far away. What intensity do they, how many watts enter their ear? Michael Watts. What the what? What you smoking? Mackenzie, holy cow, ouch. Kendra, Irmer, Gerd, that's That would melt me, I think. If you're getting really big wattages, should check something because goofing somewhere. Check your powers of 10 perhaps. Also, if you're getting more power out than you're putting in, that should be alarming. Gesundheit. Okay, one more minute for these. 2 more minutes. I mean, you could put micro on anything. And yes, your ear is fantastically sensitive. This actually sounds medium loud. You can sense 10 to the minus 12, 10 to the minus freaking, no, 10 to the minus 10 watts per square meter. 8 divided by 7 divided by 8 is 2.875? No. Quarters, for God's sake. Okay, so for those of you who are still lost, the only thing we're using is the equation intensity is power per area. You have to think about what area means, though, in each circumstance. In the first case, the sound waves spread out from my speaker, and I gave the hint that sound waves are spreading out not as a complete sphere. Speaker sits on a table that reflects things from the ground. It can't go down, so it spreads out as a hemispherical wave. 5 watts get distributed over the surface of a hemisphere by the point that it hits my ear. What is the area of a hemisphere? Well, the area of a sphere is 4 pi r squared. It's one of the things you need to know. Surface area for a full sphere, 4 pi r squared. Surface area for a hemisphere is then 2 pi r squared. 2 pi r squared is 14.1 square meters at that distance. 14.1 square meters, 5 watts of audio power spread out over that gives me an intensity of 0.35 watts per square meter. Okay, so that is how densely packed the acoustic power is at the radius away from the speaker that my eardrum sits. Well, my eardrum is a circle of a given diameter, 2.5 millimeters radius. A circle that power is, that intensity is incident on, is striking. So if I have the area of my eardrum and the intensity, power is area times intensity. Bam. Turn to your neighbor and discuss all of this, and then ask me a question. It's fine? Explain H. Did you say explain H? That's what I was just saying.
Yeah.
Okay, so again, for G, I find the intensity. First step, I think, is to find how densely packed the energy is, the intensity, at where I'm sitting. Power is 5 watts given, and the area spreads out over a hemisphere. I'm saying that the sound can't go into the ground, can't go into the table, whatever. Spreads out over a hemisphere of 1.5 meter radius. Surface area of a hemisphere is half of the 4 pi r squared of a sphere. So 2 pi r squared for a radius of 1.45 meters, 14.1 meters squared. Okay, so that's how dense the energy is. Each square meter at this distance away is 0.35 watts through it. Well, my ear is not a square meter. Oh my God, that's a weird head. Maybe the big friendly giant has an ear that big. My ear only has this much area, pi times r squared, because of the diameter of the eardrum is, diameter of the eardrum I gave you is 5 millimeters, I think. So you calculate its area. Note, again, the eardrum cross-section, the sound waves are striking as a circle. So you use pi r squared for that. Intensity times area is back to wattage. Half a second. For H, think about the structure of the formula. If radius doubles, area quadruples. If you double how far back you stand, the area subtended by that hemisphere, 2 pi r squared, plugging in 2r, quadruples. A is in the downstairs of that intensity formula, so if you quadruple the downstairs, you're quartering the fraction. And final power is just a constant eardrum area times intensity. So if I quarters, P ear quarters. I just took a quarter of 7. Bam. You did? You dead? Yeah. Sorry. I don't mean to kill. The circuit inside my amplifier has an approximate resistance of 8 ohms and is putting out the power of 5 watts. Can you find the peak voltage? Wait, no, actually, hold on a second. I'm not sure of the 8 ohms, but I am sure that these speakers are powered off of a 5-volt USB standard. No, let me redo the question here. Peak voltage is 5 volts. Peak voltage is 5 volts. Can you tell me the approximate resistance of the speaker, the equivalent resistance? 2 parts, and the RMS current. There we go. We'll practice both skills there. Peak voltage for speaker, unless I am very mistaken, is 5 volts. Find resistance of speaker, the equivalent resistance. J, find the RMS current in the speaker. Yeah, I think it's 5 watts. Yeah, no, that's what the manufacturer said. And the resistance of the speaker in the first case, and the RMS current in the second case. I gave you it's a 5-watt speaker. You need that. You can't do I without that. Hold on a second. The power you just calculated is the power delivered to my eardrum. The power, the electrical power of the speaker uses speaker power. You're welcome. You're still working, right? Who's still working? Who's still working and who's distracted? You're still working, okay. Gesundheit. Hey, I want to point something out because no one's getting I right. When I say that the power output is 5 watts, that's coming from audio signals, sine wave signals. Waves coming out, alternating current. And sound waves are alternating, audio signals are alternating current. They're just like 800 hertz instead of 60 hertz. So what kind of measurements do we use when we're talking about power? I told you peak voltage. Hint, hint, hint. Not a single person. Remember, these are sine waves. Morse code is a sine wave. If the peak voltage of that sine wave is 5 volts and the power delivered is 5 watts, what do you have to do to that voltage in order to combine it with power? Multiply what by 0.707? Yes. Then you were allowed to calculate combined with the power equations. Nope.
I'm only asking because the participation points were a little low in this class.
Participation points are not based on
I know. So I want to
correctness.
make sure that my system is syncing to.
What's your name?
Ulysses.
La CC with 2 S's?
LASI.
LASI. I do not see you.
Yeah, my participation shows that I've barely been here all year.
Show me your thing. So you should be. And we look at, this is your account. Oh, LLAS. Let me look for that in the emails. Because you could type whatever you want for name, LLAS. I will unhide that. You're logged into that. Did you hit submit?
I realized at the beginning of the semester I wasn't pressing submit. I haven't been the best about it, but
Okay. Did you hit submit today?
I will after.
So what I want you to do is be hitting submit and then edit response so that I can see how people are doing. Go hit submit right now.
Synced your system.
It is. But I can't see that it's synced once you hit submit.
Okay. That
Yeah, see about that.
I'll work on that.
And remember what I said, like, I can't give you participation points if there's no way to prove that you were here, but if I see you do well in the final, if I see you push that, I reserve the right to round up, big time. Several percent. But go hit submit and let me make sure that I got you now. And like 30 seconds, y'all, and then we'll discuss these. I got you now. Okay, womp, womp. Everybody missed one. Every bunny, every single bunny in the farm here. We would like to use the equation power equals v squared over r. Yeah, do you guys know that? V squared over r? Turn I into v over r, and this is IV, right? Do you want me to derive this for realsies? No, yes, maybe. So the fundamental electrical power is VI, right? But what if I don't have current? I want to combine voltage and resistance instead. So I is V over R, right? Ohm's law. Look, VV over R, V squared on R. Okay. And what I teach you about alternating current, sine waves, and power. Thou shalt not use peak values when doing power calculations. You're allowed to use P equals IV, V squared on R, V equals IR, all of them their equations with electricity that we're used to, but thou shalt use RMS values. So what I do here is I plug in 5 volts times 0.707 to get my RMS, and then divide that by, well, well, that would be R. I solve this for R, and I get R equals 5 times 0.707 over power was given as 5 watts. And that turns out to 7 ohms. Yeah, remember this? When you're using power, you can use the ordinary, when you're using power with alternating current, you can use the old equations, but you have to use RMS. Okay, now you've got the peak value of the voltage is 5 volts. I've got the resistance. I would like to use V equals IR. What I would do here is I convert 5 volts to its RMS voltage, 3.54 RMS volts equals IRMS times 7 ohms. 1.77 amps. I shouldn't say mix an equation with its units. Can I get part 2? I don't think you can get part 2 if you got 1 wrong. Me, I got it. Good job. Or you guys changing is, hey, you guys know, your participation points are not counted for correctness. Changing your results afterwards is kind of slightly silly, you know? There's no point to that. Yeah, please. You could. You totally could. You absolutely, positively could. It will give the same result. No difference. Make sure you use RMS voltage. Yeah. How did I get 1.77? Well, are you okay with the RMS voltage being 3.54? Are you okay with the resistance being 7 ohms? That's what we just got. Okay, so if I've got 3.54 equals 7 times unknown, how do we get this unknown out of the way? 3.54 over 7 should be. Oh, no, good God, it's not. Whoopsie, what did I do? What did I do? Oh, I thank you very much. 3.54 divided by 7. That was a test and only K money passed. 0.51 amperes. Thank you. Thank you mucho. Really? Okay. 5 times 0.707 squared divided by 5. 2.5. 2.5. I'm sorry. Several people got this right. I know plug in right, and I done goofed. And if that's 2.5, then the other answer is also, I'm so sorry, 1.4. I am embarrassed. Thank you. Thank you. Okay. Now, I'm looking around and I'm seeing souls that are almost as dead as mine. What I think I'm going to do at this point is end on a mistake, end my year of teaching on a mistake. I'm going to stick around and go over all the questions that I did with the 3 o'clock students faster than I gave the full period. You are welcomed and encouraged to stick around with that. But Merry Christmas. Let also the very last class I show some mercy for once. You may leave early, 15 minutes early. I think it's 15, right? I got that wrong last class. 5? It's, please.
So I left town, March 30th for a funeral.
Mhm.
That week before, I tried to knock out some assignments on Pearson early. It's not showing that I did homework 9 and homework 10. Now, it was in Pearson as due in 2024. I didn't know that.
Oh, no. Would you email me that? I will check. I should be able to see.
If I attempted it, right?
Yeah,
I can't see
yeah.
it on my end, but I'll email you just to.
Email me and I will.
I read out
present.
my homework and like the answer, so I wanted to just show you proof that I
Oh.
actually did do it.
I'll look. It'll have recorded your score. It'll have given penalties, which I'll take away. I'll give you the credit for it. Absolutely.
Awesome. Thank you.
Yeah. Sorry about that.
It's all good. Have a good week.
Yeah, check. Aw, thanks. Sure. Appreciate you. Okay, so which 3 of you are staying for the? Yeah, actually 10 of you. No, you're running. No, you're staying. Okay, you want to see more problems? I've got so many problems, maybe even 99 of them. Don't know. I asked her to do a sampling of everything. We talked about it. She said she's making stuff for everything. De nada, Andres. Au revoir. Hey, don't look. Secret. Okay, let's do emotional EMF problem. And let's do emotional EMF problem in a nerdy context. I've got a metal D20, 20-sided die for Dungeons and Dragons. And I'm just about to beat the big bad evil guy. Strahd can suck my sun sword. Sun sword? Oh god, it's been a couple of years. Suck my sun sword, Strahd. My paladin's gonna smite you into anyway. So I'm really excited. I'm shaking my die at 5 hertz with a maximum amplitude of 3 centimeters, 3 centimeters. And I want you to find the voltage, it'll be small, voltage induced in the die by dint of moving at the speed that you must figure out through this magnetic field of the Earth. It'd be cool if I played D&D in an MRI machine with that. That would be hilarious. It'll be small. And for what it's worth, I was sitting facing northward in my dining room, and my hand was moving in the upward direction. Magnetic field of the Earth is going north. Tell me, north, south, east, west, up, down, which direction was positive on the die? what is the positive side of the die? Which side has positive voltage? That induced EMF. Which side is positive? Again, the velocity is up, and the magnetic field is north. I mean, you don't actually need to know which way I'm facing at all. That doesn't make a darn bit of difference. Never mind. Work it out. Right-hand rules. I'm just going to give you guys some time because I don't want you guys to overwrite A, B, C, D, E through K or whatever. So I'm just going to give you some time and then I'll tell you. Find the magnitude, B, find the direction. Which side is the plus side? Ryan, that's probably what I did. I'm big silly. Oh, do I have someone sitting here? No. Oh, it's Alex. Hi, Alex. Oh, Alex, David wanted to know what you're doing in the SI session, and we talked about this, and I'm a big goof. Are you doing everything, or are you focusing on after midterm 1?
Today's SI session will be going over the equations,
Today's SI session will be going over all the equations.
And then more optics, focusing more on like the thin lens equation and magnification.
And then optics. Trying to make some sense of that. Thank you, Alex. You're the bestest. Okay, is that enough time? Here's how I tackle this sucker. I know that the formula, because I wrote it above, I know that the formula for motional EMF is LVB or VLB. Yeah, remember that? Motional EMF is the LVB. L is given, right? That's the size of the die, a centimeter. B is given, Earth's magnetic field. What's V? Well, let me ask you this. How am I shaking a die? What kind of motion is this? This steady motion, accelerated motion, sinusoidal motion? I would approximate this as a sine wave, probably. So I'm telling you the frequency and amplitude, that should maybe trigger some memories. If you remember, once upon a time, we discussed V max equals A omega. You got simple harmonic oscillatory motion. There's that connection being velocity, amplitude, and angular frequency. Now, what's angular frequency? Angular frequency is 2 pi f. So I plug that in, I get 2 pi fa. That's velocity max. At the end of the day, I want induced EMF. So I would do L 2 pi fa B, and I get what? 1 centimeter times 2 pi times 5 hertz times 3 centimeters times magnetic field of the Earth. And plug in any number. And I get very close to half a microvolt. Which you can also totally call 4.9 10 to the minus 7 volts. That's the magnitude. Now what about les directions? I'm going to pretend the front of the class is north. I'm going to face north, and the formula is QV cross B. Let's find which direction the positive Q's are pushed. V is up. I tell you, my hand is moving in the upward direction. B is north. If that way is north, which way is that? That's west. Never eat shredded waffles is west. or my left. Okay. I shouldn't have done this as the first one for the 3 o'clocks because they suffered. Ask me. I see faces suggesting that maybe this is hard for you all as well. VLB. VL, I mean, velocity is along the, wait, hold on a second. No. Velocity can't be along the length. It's VB, gives you force on the positive Q's. There we go, QVB. First vector V, second vector B. Resultant is force. Well, the positive charges get pushed west. Q being negative for electrons, those get pushed east. Positive voltage is the side that the positive charges are pushed. What, of course, actually moves is the electrons move east, leaving positives behind. You okay with this? You happy with this? You don't like this? Tell me why. Tell me where. Okay. Well, let me encourage you, like I encouraged the 3 o'clock. Let me encourage anyone who's watching this video. Thou shalt make thine equation sheet early. Make it early. And then when you're taking practice tests, going to SI sessions, doing homework, doing anything, you want to see if you're going to know it for the final. You want to see if you're prepared for the final. Use that equation sheet. Don't use your notes. Use that equation sheet. If it's not on there and it's not in your head, you're not going to get it for the final. Use that and see what are you missing. If you have to go to your notes, then transfer that over. Or, study it long enough that you memorize it. Use that as a checklist. And you can do that with all the resources that I've given you. We'll pretend that's north. I'm going to face north. That's the direction of the field, magnetic field. V is the first finger. Q, V, B is the middle finger. Which direction is your thumb point? If that was north, no. Yeah. Yeah. So if your dice equally go up and down, then it'll shift to east, being the positive side. It can be a current flowing through the die. So voltage. It's a sinusoidal voltage. Sometimes it's plus on this side and minus on this side. Sometimes it's plus on this side and minus on this side. And it will oscillate back and forth sinusoidally. If we average it out. Yeah, average it to 0. Yeah. You've got just as much up velocity as down velocity. Meh. Don't look, close your eyes. So with all these problems, when I talk about north, south, east, west, I never, ever can do it thinking about the paper. I always have to imagine one of the walls as north. And I know if that's north, that'll be east, south, west. Do it with respect to the room. That's up, right? I mean, like, forget about papers. That way is up. That way is going to be, make it up north, whatever. Yeah, I feel the same way. Okay, what is the EEC voltage in my wall outlet? What's 120? I'm going to tell you 120 is. Wall voltage of 120 is the RMS voltage. RMS voltage is one of the things that you used. We used a whole bunch in that homework set and on that quiz, I think. So 120 equals RMS. What's the formula connecting RMS to peak? Solve solve. at 170, 169 point something RMS. Oh, I can prove that, but stick around after class though. Well, it takes calculus, but I'll hand write the calculus. Okay, effective resistance of my 1200 watt microwave. You're using power in alternating current, so thou shalt use RMS voltage. My first step, well, I'm using the equation that I did before. Power equals V squared on R. So R equals P, V squared on P. And thou shalt use the RMS. 170 squared RMS. No, I'm such a big silly. R120 is the RMS. As for resistance, yeah, there we go. I get 12 ohms. No looky, close your eyes. Reversed. Ohms. And I already did that one for y'all. Okay. Here we go. Okay. Transformer drops 120 to 5 volts with a 50 turn primary. Find the number of turns in the secondary. This is kind of, do you know the equation? And I'll give the second one here. Oscillators, we didn't do this in the 430. Oops. How many times does Big Ben's pendulum swing in 1 minute? Number of oscillations per 1 minute. This. Fifty turn primary is the side connected to the input. That is what primary means in electronics. And again, I don't want my wife to kill me, so I'm going to move this on. V2 over V1, then 2 over N1. Or you could say 1 over 2 equals 1 over 2, doesn't matter. Output over input equals output over the input. And this does not end up as a round number, so I'm going to round to it's about 2 turns. Yeah, it must be. You just took the reciprocal both sides for me, or vice versa. How many times, how many cycles in 1 minute? Yeah, good. Okay, for G, the core formula that you need to know is omega is root G on L. Plug this in, and I get, let's say, 9.8 divided by 3.9. Is it? And then more importante, this is radians per second. If I want to turn this into cycles per minute, what I could do is I could say 1.6 radians per each second. How many seconds in 1 minute? There's 60 minutes in 1 second, right? No, think about it. 60 seconds in 1 minute. Watch out for that. Times how many radians in 1 cycle? How many cycles in 1 radian? 1 cycle is 2 pi radians. This is equivalent to turning omega into frequency and then saying frequency is what did I say? Frequency ends up being like 4 seconds? No, a quarter? No, 4. What did I work it out to be? 4 seconds. Yeah, 4 seconds. So if it takes 4 seconds, if the period is 4 seconds, takes a quarter of a hertz, you could say that it takes 60 seconds, 15 cycles happen. I think I said that backwards. You could also treat this as a unit conversion here. Radians per radian, seconds per second, I turn into cycles per minute. Questions? Omega divided by 2 pi. That's what happened here. Multiply 1 over 2 pi. Same thing. That's regular frequency, cycles per second. And if you got so many cycles per second, how do you get cycles per minute? Almost done, y'all. Really almost done. Know it or you don't. Know it or you don't. Know it or you don't. 1 equation, and then we're done. I think. Yeah. Keeping it real, man. Okay. The only lens that makes a real image, as we did before, converging. In ray tracing, this defines converging lenses through the far focal. Then for here, I have 2 equations. To find height, I need object position, object distance. So I use 1 over f, so 1 over di plus 1 over dou. What is that? 1/10 equals image distance plus 1/25. That gives me a image distance of 17 centimeters. And at the end of the day, I do magnification equals di over dou. Actually, negative. Negative is just being picky. It's a flipped image is what the negative sign gives you. 17 over object distance is for God's sake, where did I put it? 25 centimeters. 17/25 is 2/3. Negative, to be picky. I would give you full points with, if I'm asking for just height, I'm not gonna, that sounds like a scalar to me. I'm not gonna ask you that it's negative. For what it's worth, you doctors, if MCAT asks where they have negative image heights, that's just inverted. I didn't make a big enough deal about that for, okay, so negative 2/3 of 3 centimeters tall. Bam, done, end of semester. What do you mean? Di is a positive number. Dou is always a positive number. I mean, I just plugged into the formula and I got di as a positive number in this case. Magnification, yeah, here's the magnification formula. Magnification is negative di over dou. That doesn't mean that di is negative. If I take negative of di over dou, 17 becomes negative 17 over blah, blah, blah. Oh, I should say a word or two about, it is the end of the semester and I have no wisdom to give you other than, in the immortal words of Bill and Ted, be excellent to each other. There we go. Those are my final words for the recording.